Hello, I'm Bryan Atkinson and welcome once again to UK Aircraft Explored. In this video we shall cover the wireless operator's position within the Avro Lancaster bomber. We shall be referring to the 1944 Air Ministry manuals. I hope you find this interesting. The wireless operator's position is located just after the navigator's position on the port side of the aircraft. The wireless operator's seat is on the port side integral with the front spar cover and step, and faces forward. It is a box type seat built up with light alloy flanged U-section stiffeners and skin. The seat is supported on a frame of welded mild steel tubes bolted to the main floor. The wireless operator has a square window located to the left of his seat. A T.1154 transmitter and an R.1155 receiver, an amplifier and a crystal monitor are all mounted on a transverse table at the rear end of the navigator's panel. A TR9F, when fitted, is below the table. Alternatively, a TR.1196 is mounted on the port side just after the rear spar. The wireless operator's oxygen cut-off valve and the Mk.//TEL distribution panel are on the port side above the window. Now just forward of the window is the R.1155 or R.3090 control unit. Fitted to the right of the table is the Morse Key Type F. At the end of the table is a hinged flap which could be lifted to obtain access to the stowage of various required items of equipment. Now let's look at the equipment in greater detail. The wireless operator's T.1154 transmitter and the R.1155 receiver are mounted on the rear face of the radio panel, which is fitted transversely across the table facing the wireless operator. The sets may be connected to either the main fixed aerial on the starboard side or to the trailing aerial by means of the aerial plug board or aerial switch. The winch for the trailing aerial, together with a spare reel, is located on the port side below the table, just forward of the wireless operator's seat. An HT power unit type 33A, an LT power unit type 35A and a relay type 220 are mounted on a stool on the main floor, centrally beneath the table. Here are some details covering the T.1154 transmitter. The most obvious feature of the T.1154 transmitter are the three coloured knobs located on each side of the front case. The transmitter could send messages on 3 frequencies. Each knob could be set for free range tuning or preset to a certain frequency by using the multi-click and uni-click systems located to the left of each knob. Their letter presets and a free range position can be seen in the photograph. Here are the frequency types represented by each colour. Yellow for low frequency range, red for medium frequency range, and blue for high frequency range. Here we have a close-up view of 2 meters mounted at the top of the unit. On the left is the mag feed power level meter used to check the electrical power coming into the unit. On the right is the Aerial Ammeter used to check levels of static electricity on the MF aerial. It was used on the medium frequency range only, hence MF. The frequency range switch is located at the lower left of the unit. The three colour range selections can be seen along with the frequency coverage of each frequency as follows. Here is a view of the notation panel mounted at the front of the unit. Before each flight, the wireless operator will be given a list of frequencies to be used during the operational sortie. He would then set up the coloured preset frequency selectors to suit. To help him remember which letter each frequency was set to, he would make a note of the mission frequencies names on the panel above. After the mission, the penciled writing will be rubbed out in readiness for the next sortie. The notation panel was actually fixed to the T.1154's valve inspection cover of around the same size. The master control switch, shown here, was designed to set the T.1154 into various modes of operation. It could be set in the following positions: off, standard by, tune, CW, MCW and RT. These are the power output controls. They are used to vary the strength of the transmitted signal. As can be seen above, there is a colour coded control for each frequency, i.e. yellow low frequency, red medium frequency and blue high frequency, as we've said before. We'll move on now to the R.1155 receiver. The R.1155 was the standard receiver fitted to the Lancaster, and indeed most Bomber Command aircraft throughout the war. It was designed to be used in conjunction with the T.1154 transmitter. We'll now have a look at its controls. Located at the bottom left of the unit is the frequency range switch. It will be used to change the mode of receiving to one of the following: yellow for low frequency, red for medium frequency, blue for high frequency and black for the direction finding loop frequency. The function selector control is located at the lower right of the unit, just above the power, aerial and the DF loop connectors. It allowed the switching to manual gain, automatic volume control, DF balance, DF visual and DF audio settings. In this close-up view of the top left of the unit are the DF meter balance control, the meter switch and the DF meter amplitude control for use when the visual setting of the function selector switch. To the bottom of the picture is the volume control knob. This is the R.1155 tuning dial. Here you can see the tuning ranges across all frequencies of the dial. As with any radio, the operator would turn the tuning knob to move the frequency indicator across the dial until the required frequency was found. As mentioned before, the yellow band is for the low frequency, the red band is for the medium frequency and the blue band is for the high frequency. The black band is used for the direction finding purposes with the DF loop. The controls shown in this photograph of the top right of the unit are, starting on the left, the tuning indicator, which was a visual aid for tuning into a frequency. The operator could actually see a green shadow representation of the signal, and as he tuned in, he could use this to sharpen the image and thus tune in more precisely. To the right of the tuning indicator is the meter deflection sensitivity switch, providing a high-low setting position for meter use when the set was in visual mode. To the right of this control is the Aural sense control, used when listening for the DF transmissions and determining the direction of the homing signal. Finally, on the far lower right is the DF loop switching speed control. A trailing aerial winch is located on the port side below the table, immediately in front of the wireless operator's seat. This aerial should be reeled in before the bomb doors are opened. Access to the winch is obtained by lowering a sliding door in the panel heating baffle. A spare reel is stowed under the step at the front spar. Once the aircraft was airborne, the wireless operator would extend the trailing aerial using this reel. The aerial is believed to have extended up to 40 feet behind the aircraft's tail, although I haven't been able to verify that. The purpose of the trailing aerial was to improve the signal range of transmission and reception. Normally, a cover would be fitted over the reel to protect the operator from high levels of static electricity from the aerial. Once the aircraft had returned to base, the wireless operator would have to reel in the aerial to prevent it from becoming tangled with the tail wheel. As an added incentive to wind in the aerial, if a forgetful bomber crew didn't wind in the aerial prior to landing, they would be charged 5 shillings to have the ground crew re-spool the reel, as it was a very fiddly job, a task that would reward the ground crew with the free night down the pub. Here is a view of the wireless operator's Oxygen Economiser. The Oxygen Economiser worked by having a diaphragm valve fitted in a shut position. When the crew member inhaled, the suction would open the valve. This valve would therefore stop oxygen being pumped into the mask when it wasn't needed. The red and green sockets in this photograph are the cross-coupled alternator sockets. The idea being, if one alternator failed, the operator could switch the connection to the other, hence the red and green colouring to differentiate between the two. Oxygen economisers were provided for all crew members and located at various points in the aircraft. The oxygen bottles are stowed in a crate which forms the frame of the rest couch in the intermediate centre portion of the fuselage, and a main high pressure cut-off valve is provided at the front end of the crate. Portable oxygen bottles are also provided at each crew station in mesh holders, as shown here. Here is a view of the IFF, that's the Identification Friend or Foe, Mk.II control box, which is located to the left of the wireless operator's station. The system was a transponder which transmitted a special signal that could be picked up by Allied operators in the home chain radar stations. It was a quick and effective means of differentiating between Allied and enemy aircraft. Here is a diagram illustrating the system in the aircraft. The original TR9F installation was replaced in later aircraft with the TR.1196, as shown in this photograph. This high-frequency radio is fitted on a mounting plinth on the floor beneath the navigator's table. In later production Lancasters, it was fitted at the rear of the aircraft to make room for the H2S radar and B.Mk.II equipment. This transmitter-receiver was designed for communications between aircraft and the control tower when returning to the base airfield. It had a frequency range of 4.3 to 6.7 megacycles per second, in a maximum of 4 spot frequency channels, and used the RT and MCW wavelengths. In the rear portion of the canopy, above the fuselage, is mounted a direction finding or DF loop. Located to the left of the wireless operator's seat is the visual indicator Mark I, mounted next to the intercom junction box. The pilot and the navigator also had the same unit installed. It is used to provide a visual indication of the direction finding homing signal. Moving on, here's a view of the Amplifier Type A1134A intercom box. Located on the left fuselage side, just after the wireless operator's seat. All Lancaster crew members wore standard leather helmets containing earphones and microphones. Each crew position had an intercom socket into which the flexible cable from the flying helmet could be plugged. All of these sockets throughout the aircraft were combined at this amplifier and junction box to ensure that all crew members could talk and listen to each other during flight. It was also possible for each crewman to connect up to the aircraft's transmitters and receivers using a switch on the amplifier. Mounted to the left of the T.1154 transmitter is the aerial switch unit Type J. This important piece of equipment is mounted on the partition between the wireless operator and navigator stations. Early Lancaster aircraft were fitted with a slightly crude plug board system, and when the Type J switch unit was introduced, it made the transitional switching from one setting to another much simpler, with the switching done with just one control lever. Located just above the aerial switch unit is the ammeter. It was used to show the static charge build-up in the aerial. In Lancasters fitted with the H2S ground radar system, the Fishpond indicator Type 182A was fitted to the left of the R.1155 receiver. With H2S radar operation, the closest object would always be the ground, and as soon as the H2S radar pulse hit the ground, the reflection pulse would be reflected back to the H2S scanner. However, in order to locate an attacking enemy aircraft, the central region of the H2S trace between the Lancaster and the ground would be used. This area of the radar pulse would be displayed only on the Fishpond indicator operated by the wireless operator. Fishpond had a fixed range of 5 miles and could detect an incoming enemy aircraft within that area as long as it was below his aircraft. The system was called Fishpond because the radar sweep on the PPI display, that's the plan position indicator, left a region of ground return noise or grass around it, making it appear rather like a fish pond, the enemy aircraft being the fish. The wireless operator would be constantly watching his fish pond display for any sign of incoming blips, and would rotate the bearing scale on the display to give him his own aircraft's course. He could then work out the direction the attacking aircraft was coming from. To work out the range, the operator would press a white marker button to display 5 range marker rings, each ring representing a mile. He would then know the distance of the incoming aircraft. He would then call the pilot and advise him to take the necessary evasive action, usually in the form of a corkscrew, a violent turning manoeuvre that saved many a bomber crew from attacking aircraft. Fishpond was very successful and also helped track Allied aircraft in the nighttime bombing stream that may be below the aircraft. Well, that's it for this video. If you like what I do on this channel, please click the like button and please subscribe, and also click the bell. Remember, it's free and you'll receive notifications when my future videos are posted. Thanks as always for watching, and I'll see you again next time. Bye for now.